Okay, everybody. So the reason why I taught you how to find the geometric mean is because we're going to be using it to find missing sides found in right triangles that contain similar right triangles within the right triangle. So it's like a lot is going on. We're going to have right triangles within right triangles. But the more right triangles, the better, right? Okay, so proportions for the altitude drawn to the hypotenuse of a right triangle. Okay, so if you guys see here, I have a right triangle. Triangle ABC is a right triangle. Now, segment CD, whenever you draw a segment, that forms a right angle. Now, technically, this is perpendicular to segment AD, but there's a special name for segments that you draw in a triangle that form a right angle when you hit the other side. Okay, so an altitude is something that when you start from one side of the triangle and draw a segment to the other side, if it hits the other side at 90 degrees, that is called an altitude. So segment CD is an altitude. Okay, so if the altitude is drawn to the hypotenuse of a right triangle, so this altitude intersects with the hypotenuse, segment AB, which I know AB is the hypotenuse because it's the side directly across from the right angle. Okay, so if you draw an altitude from the right angle of a right triangle to the hypotenuse, then it will form two similar triangles. Okay? And also, those two similar triangles will be similar to the original triangle, which is cool. Okay, so do you see triangle ADC as well as triangle CDB? Okay, these two triangles will be similar, and also they'll be similar to the large triangle. So triangle ABC will be similar to HCD, which will also be similar to CBD. So that's kind of cool. Now, if you ever have similar triangles, guess what that means about their sides, you guys? It means that sides are proportionate. So we can use proportions to help us find missing sides of the different right triangles in the picture. And again, the way that we solve a proportion is by cross multiplying. So if you like to cross multiply, guess what? We're going to keep on doing it. Okay, now there are two cases that we can use to help us solve for the missing sides of right triangles that are within right triangles, and it's based on the information that's given to you. Okay, so the length of the altitude is the geometric mean between the segments of the hypotenuse. Okay, so if you are given an altitude length in your picture, like if you are given the length of the altitude, or if you're trying to find the altitude, this is when you're going to use this formula. Okay, so in my formula, ALT means altitude. POH is a piece of the hypotenuse. Like AD and DB are pieces of the entire hypotenuse, which is segment AB. Okay, so this is like one piece of the hypotenuse. I'm going to call it piece of hypotenuse 1. This is the other part or piece of the hypotenuse. So I'm going to call it POH2. Okay, so if you are either given the altitude in the triangle or you're solving for it, you are going to use this lovely formula. You're going to set one piece of the hypotenuse over the altitude, which will equal the altitude over the other piece of the hypotenuse. Okay? And if you guys see here, we're solving a geometric mean because two of our parts of our proportion are the same. The altitude, we're going to have the same value in the denominator as well as the numerator. Okay, so this is going to be one case that we use. Now the other case, okay, if you are not given the altitude, but you are given one of the legs of the right triangle, so one of the sides of the right angle, this is when you're going to use this formula. So, if an altitude is drawn to the hypotenuse of a right triangle, which we've been talking about, the altitude is drawn to the hypotenuse of the right triangle, then the length of one of the legs is the geometric mean between the adjacent segment of the hypotenuse and the entire hypotenuse. So, I know that's a lot to take in, so let's talk about what that means. Okay. So, in my picture, you use this formula if you're either given or you're trying to find one or two of the legs. So the legs are the sides of the right angle in the right triangle. Okay, so the formula that we're going to use, HYP is the entire hypotenuse Okay, so segment AB. POH is one piece of the hypotenuse, so either the first piece of the hypotenuse or the second, and leg 1 or leg 2, so the leg length given in the problem. Okay, so when we do this, okay, you're going to set the hypotenuse, so the entire hypotenuse, over one of the legs will equal the same leg over the part of the hypotenuse that is closest to that leg. So leg 1, the piece of the hypotenuse that's closest to leg 1 is POH1. Okay, so leg 1 goes with POH1, which if you guys see here, it's a geometric mean because two of my parts of my proportion are the exact same along the diagonal. Guys, or if you're given the other leg, it's going to be the entire hypotenuse over the other leg, which will equal the other leg over the piece of the hypotenuse that's closest to this leg, which if you guys see here, the piece of the hypotenuse that's closest to this leg is POH2. Okay, so when you're doing this, like leg 1 goes with POH1, leg 2 goes with POH2. And again, this is a geometric mean because along the diagonal, I'm going to have the same value. Okay, so we're going to use these two formulas, which I have up here, to solve for different side lengths that are missing in our triangle. Okay, so we're going to start with example 3. So let's get going on example 3. And I really hope my thing isn't frozen. Okay, it's not. Okay. Sorry guys, me and this document camera don't get along a lot of times, but it's okay. We went through bestie counseling and we worked it out, so it's okay. Okay, so again, I have our two formulas here. One we use when we're given an altitude, so the little segment that makes a right angle when it hits the hypotenuse. The other formula we use when we're given a leg. And don't forget that since the diagonals and all these formulas are the same value, okay, these are geometric means. Okay? All right, well, let's get going on our first example, example 3. Okay, so we're going to find x and y. Now, for the first problem, I'm going to act like that y is not there. So we are ignoring the y. Okay, so I'm going to put this over the y because I don't care about y right now. It is not in the problem right now. I'm ignoring it. Okay? So when I'm deciding which formula to use, I need to know, well, am I either solving for or am I given an altitude or a leg? Okay, if I cover up the y is one of the legs of the right triangle because it's on the right angle. Okay, so the x is currently sitting in the altitude spot. Do you guys see that? So since I'm either, in this case, I'm solving for the altitude, you're either given the altitude or you're solving for it. Okay, that is telling me to use this formula. Okay, later on when we talk about the y is a leg. So that is telling me to use the other formula, but we'll get to that later on. So I'm still ignoring the y. Okay, so since x is located on the altitude, that is telling me to use this formula. Okay, so I'm going to write that formula real quickly. So I'm going to write POH1, let's see here. Okay. So the piece of the hypotenuse 1 equals the altitude, POH1 over the altitude equals the altitude over the second piece of my hypotenuse, so POH2. Okay, and then from here we just fill in our formula, which, sorry guys, I'm being really sloppy today with my writing. Jeez Louise, Miss Long. Okay, so let me fill in my values real quickly. Oh man, come on, Miss Long. Get it together. Ah! Okay. Sorry, that was a demon cat. That's what demon cats sound like, so watch yourself. Okay. So, POH1, so one piece of the hypotenuse. It really doesn't matter which piece of the hypotenuse you use. I'm just going to call this one POH1, and I'm going to call this one POH2. So this is one piece of the hypotenuse. This is my second piece of the hypotenuse, and x is going to be my altitude. Okay, so let's just fill in our formula, and after we fill it in, we just solve for x. Okay, so POH1 is the 4, and that'll be over my altitude length, which is what we're solving for, so the x, and that will equal x over, because it's my altitude, over my second piece of the hypotenuse. POH2 is 5. And then from here, you guys, we just solve like we did in example 1 and 2. We cross multiply a bunch. Okay, so let's get going. So, x times x is going to give me an x squared. And x squared will equal 4 times 5. Which 4 times 5 is 20. Okay, and then how do we undo a squared? We do square root that thing. Okay, I'm going to square root it on both sides. Bam and bam. Which the square root will cancel out the squared. So I'm left with x equals. Now technically, you guys, remember when we square root both sides, what will appear in your answer? Technically, a plus or minus should appear. But like we talked about in example 1 and 2, we're solving for an altitude length in this triangle. You can't really have a negative altitude length. Okay, so in my final answer, I'm not going to include the negative. Okay, but for now, I'm going to include it just so we don't forget, because later on when we start our next unit, or our quadratic unit, okay, when we start that unit, this is going to happen all the time. So I don't want us to forget that. Okay, and is root 20 a perfect square? No, it is not. So how do you deal with something that's not a perfect square? You do a factor tree. Holy to the hot dog, right? All right, let's break it on down. Break down 20. So 20 will break down into 4 and 5. And 4 will break down into 2 and 2. Okay, so my final answer. Do you guys see any cute little couples at the ends of my branches? I do see the 2's. Do you guys see the 2? Whoa. So my pair of 2's will come outside my square root. And then my lonely single number. So my pair of 2's get to go on their math dates. The lonely single 5 has to stay in for the night. Poor 5. Okay, so x is going to be 2 root 5. And that's how you find x. Okay, so in this problem, we're now not going to look at x. So just pretend when we're solving for y over here, sorry, I have this little piece of paper in my hand. Sorry, guys. Okay, so when we solve for y, I'm going to act like this x is not here, which I don't really have anything to cover up the x with. So just pretend like that's not there. I'm ignoring that. Okay, so if you are solving for, or if you are given a leg, which if you guys see y is on the leg of my right triangle, it's on one of the sides of the right angle. So when you're given a leg, that's when you use one of these formulas, which depending on which leg you get, depends on which formula you use, which they're the same formula, you guys. It's just that when you do the formula, the leg and the piece of the hypotenuse that you use are very important. Okay, so this formula says you're going to use the entire hypotenuse over the leg, which in this case, the leg is the y. And that will equal the same leg, so the y, over the piece of the hypotenuse that is closest to the leg. Okay, which in this case, that's going to be POH1 if it's leg 1. If it's leg 2, the piece of the hypotenuse that's closest to it is POH2. Okay, so that's the formula we're going to use. I'm going to call y leg 1 just to make things easier. Okay, so my formula is going to be, okay, we're going to have leg 1, or no, check LOL. We're going to have the hypotenuse, so the entire hypotenuse of the big triangle. So hypotenuse over leg 1, which is going to be our y, equals leg 1 over the piece of the hypotenuse that's closest to leg 1, which in this case is POH1. Okay, so remember, leg 1 goes along with POH1. Leg 2 goes along with the piece of the hypotenuse closest to it, which is POH2. And guys, remember, this is a geometric mean because along the diagonal, I'm going to have the same value. Just like over here, along the diagonal, I have the same value. Okay, we have the x. Okay, well, let's fill in our values, you guys. Let's go. Let's solve this thing. Okay, so the first thing, I need to know the entire hypotenuse. Currently, I only know pieces of the hypotenuse. Okay, so if I know this piece of the hypotenuse is 4, and this piece of the hypotenuse is 5, how how do I find the entire hypotenuse? How do I find the length from here all the way to here? How do I find the hypotenuse? Well, I'm going to add these two together. So the 4 and the 5 will give me 9. Okay, so the entire hypotenuse is going to be this piece plus this piece, which is 9. So my hypotenuse is 9. Okay, leg 1 is what I'm solving for, which is y. So I'm going to put a y here. Leg 1 again is y. And the part of the hypotenuse that's closest to my y is POH1, which in this case is 4. Alright, and from here, we just cross multiply. So let's do it, you guys. So y times y will give me y squared. And that will equal 9 times 4, which is 36. Alright, let's do this thing. How do we undo a squared? We do square root that thing. So I'm going to square root that thing on both sides. Bam to the bam. Okay, so the square root of a squared will cancel out. They're inverses, so they cancel each other out. Okay, so we're going to end up with y equals this. Now, technically, when we square root both sides of our equation, what will appear? Plus or minus. Good. And then, is 36 a perfect square? Can we actually, like, square root a number for once instead of having to do these factor trees, which factor trees are, like, really fun. But every once in a while, it's nice if you find a perfect square. So is 36 a perfect square? Yes, it is. And the only answer that makes sense, well, y is a leg or a side length of my right triangle. So a negative 6 does not make sense. So for my final answer, I'm going to say y is 6. Okay, well, that is all there is for example 3.